biochar is the core of my research interest in the past few years. And just to really briefly introduce, biochar is a carbon-rich material, really similar to activated carbon. And it's produced with a process so-called pyrolysis, which is a high-temperature thermal process and in the oxygen-limited environment. So it's not like incineration. It's not like just burning with open flame. It's different. And then through this pyrolysis, we getting as a solid phase of, and that material is biochar. And then, so biochar can be produced from different feedstock. For example, lignocellulosic biomass, which is a wood chip, so a byproduct or waste from forestry. And there's agricultural byproducts and waste through, and in the end, we can land on sewage sludge or biosolid. Then yes, we can produce biochar from sewage sludge. Why is this good? This is good because sewage sludge is a byproduct of the wastewater treatment, and then it's unavoidable. So while people on the earth, they're going to generate wastewater, that wastewater, if we want clean environment, needs to be treated. If we're treating wastewater, there's going to be sludge. And that's a fact. But what we are doing with that sludge and which impact that sludge have on the environment, that's a different story. So what we are doing with that sludge, we in UK, it's most of it is ending on the land as kind of like a soil amendment thing, or it's going on the landfill. Or in some communities, example, for me from Thurso, the closest is Shetlands, they have like incinerator. So they burning it, but it's not a pyrolysis, it's a different thing. So when we're talking about then it's on the land or in the landfill, it's full of, again, with this cocktail of different chemicals. It's full of pathogens, full of plastic, microplastic, but also full of useful stuffs like nutrients, macroelements, and organic, useful organic stuff. But because of these other things, it's not that easy to use just like in a raw form. So here comes pyrolysis, and then we're transferring that to a biochar. And then what we are doing, because of the nature of the thermal process of the pyrolysis, basically we're destroying most of the organic contaminants, because most of them, like pharmaceuticals and pesticides, are not designed as flame retardants to exceed that heat of 500, 600 degree. We're destroying the plastic in the material. We're destroying all the pathogens. So we're cleaning up the product, but also we're locking up carbon, because carbon in biochar is a stable form of carbon, which can last in the soil for a very long time. So why is good is to transfer, because we're ticking all these boxes and cleaning up the sewage sludge, and then producing the material which be much cleaner and then can be used for different purposes.